In this section, we'll talk about the measures of center. So we've already talked about how to perform a survey. We've talked about how to organize all your data. So now we're going to go into the analyzing part of it. So first thing you might want to know is where's the center of your data? If you have a bunch of data points, right? What could we call the center of it? So there's a couple different ways that we can talk about that. The first one is called the mean. This is the one that most people think of when they think of trying to find the center of something. And mean is just found by, it's computed by adding all the values of the variable in the data set and dividing by the number of observations. So the way you find the mean is you add up all the values and then divide by the number of values. Does that sound familiar? Maybe an average? Yeah. So when we say mean in statistics, all we mean is average. And we have two different types of means that we'll talk about in this class. We have one for a population and we have one for a sample. So the population mean is the big one for every single person in your population, right? And this is the way that we write this is with a Greek letter mu. So it kind of looks like an M and a U had a baby. It's a Greek letter called mu. That's the one we use. It's important to know that. So this mu is going to be a parameter, right? That's computed from all the individuals in the population. The reason why it's parameter is because it's for a population. Likewise, a sample mean, we're going to write it as x with a bar over it. So also known as x bar. So if a population mean is the parameter, what's the sample mean going to be? It will be a statistic. So both are found the exact same way. You just add them up and divide by the total. All right. So let's look at an example. A student counts the number of chocolate chips in different cookies. Find the mean of the first 5 counts for the chocolate chips Ahoy regular cookies. All right. So how do we find the mean? We just add them up. So 22 plus 22 plus 26 plus 24 plus 23. And then we divide by the total number. So 1, 2, 3, 4, 5. And when we get that, we should get that would be about 23.4. And by about, that's exactly 23.4 chocolate chips. Now the question is this going to be a population mean, mu, or is it going to be x bar? Is this all of the cookies, or is this some of the cookies? So if you notice, it says the mean of the first 5 counts. So if it's the first 5, that means that there would arguably be more after that. So this would just be a sample. So this would be x bar. So x bar is 23.4 chocolate chips. All right, let's look at example number 2. Hopefully that was easy. So now let's do a little harder one. So a box of 5 cookies have an average of 20 chocolate chips per cookie. If someone forgot that the package actually contains a 6th cookie with 24 chocolate chips, let's calculate the new mean. So let's calculate the new mean. All right, so this box of cookies we thought had 5 with an average of 20 per cookie. However, there was actually 6 in there the whole time. So how are we going to do this? So some people might think that we would do 20 chocolate chips plus the 27 chocolate chips divided by 2, and that would give us 23.5. However, that is incorrect. Why is that incorrect? So let's think about this for a second. How many cookies do we have? So notice this is the 6th cookie. So this number should be 6, not 2, right? But we're not adding 6 numbers here, right? Remember, the whole thing is we add up the number of cookies, and then, or you add up the number of chocolate chips in each cookie, and then you divide by the number of cookies. But we're only adding 2 numbers. So where's the problem? Well, how many cookies had an average of 20? 5, right? So in actuality, it's not one cookie has, we can think of it not just as one cookie having 20 chocolate chips, but 5 cookies having 20 chocolate chips. So it would be 20 plus 20 plus 20 plus 20 plus 20, right? Or 20 times those 5 chocolate chips, right? So now we have 6 cookies with chocolate chips divided by 6. So this is what we're looking at. So when we add 25 times, add it to 27, and then divide by 6, right? We'll get about 21.2 chocolate chips. And now again, is this going to be the mu, the population, or is this the sample? Well, if we're talking about the package itself, right, being all the cookies, well, if this package has 6 cookies in it, that's all of them, right? So that would be the population of that package. But if we were talking about the population of all chocolate chip cookies in total, not just the one in the package, obviously that would be a sample. So it just kind of depends on what we're talking about. All right, let's do another one like that, because that was a little trickier. So 9 men have a mean of 180 pounds. If another man weighs 165 pounds, what's the new mean? So again, if we think about it, how many men do we have now? So we have 9 and then an additional one, so that'd be 10. So we need 10 numbers up here on top. Well, how many 180s do we have? It's not just one, right? It's 9. So you can add 180 plus itself 9 times, or you can just multiply it by the 9 people, right? So here's 9 numbers. What about that 10th number? Well, that's just going to be that 165. So when we add 180 9 times, and then add 165 to it, after dividing by 10, we get 178.5. Now again, is this going to be the population mean, or is this the sample mean? Well, there's no indication that we just have 10 people in whatever we're looking at, right? So this would probably just be a sample. So the sample mean is 178.5 X bar. All right. If you have any more questions about that, as always, feel free to email me or text me about it. All right. So that's one way that we talk about it. The second one we have is called the median. So some of y'all might be familiar with this in maybe like elementary school or high school or something like that. But the median lies in the middle. So this is more of a location scenario. And it's in the middle when everything is arranged in ascending order. It's just literally the one in the middle. So there's not a lot of math involved with this. We're just trying to figure it out. So in this case, sometimes you might see that M is the median. Sometimes it's X tilde with a little, like Spanish tilde. It's not super important. We don't use median nearly as much as we use mean. So it's just, these might be something you see in the homework or something, but I wouldn't worry too much about these symbols. Now the mean symbols, super important. You definitely need to know these. Median, not as important. Excuse me. All right, so let's find the median. So example number 3, here's a list of data, find the median. So remember, first we have to put them in ascending order, so they need to be in order. So we got 0.42, 0.48, 0.66, 0.73, 1.1, 1.1, and 5.4. So, looking at the center, what number is that? So we notice that we can cross off 3 on the front, 3 on the back. So our answer for the median is going to be 0.73. That's our median of this data. All right, let's look at part B. So let's find this median. So again, you put them in order. So if you notice, these are actually the exact same numbers, except we don't have 0.66 this time. All right, to find the middle, take the first and last. Well, this time we have 2 numbers. Well, we can only have one answer for the median. You can't have 2 answers for the median. So what number is in the middle of these 2 numbers? How could we find that? Well, we could find the average of the 2, right? We could find the mean of the 2. So if you end up with 2 numbers in the middle, all you need to do is just add them up, divide by 2. And we end up with 0.195. So the median, in this case, is 0.915. All right, hopefully that wasn't too hard, so let's do a hard one. Find the missing data value with the given median. So we got 1, 14, 17, something, 20, 38, 50, 53, and the median is 18. So what number is going to go right there in the middle? Hopefully you can see pretty easily, since there's 3 on this side and 3 on this side. Since the median has to be 18, the number we're missing is just 18. Easy. So that wasn't the hard one. Yeah, part B is the hard one. All right, so now let's find the missing value. So this time the median is 25. We see that the first 2 numbers and the last 2 numbers can be canceled, so we actually end up with 2 numbers in the middle. So how can we figure out what the median is? Well, there are a lot of ways of finding this. So if you want to kind of pause it, try to figure it out on your own. How do you figure out, well, not what the median is, we know what the median is. How do you figure out what number is missing from there? So if you want to take a pause, figure it out on your own, and then come back and see if you get the same answer as I do, totally cool. Otherwise, I'll try to do 2-ish ways of doing it. If I can think of any more, we can do those too. Like I said, don't have to do it the way I'm doing it, but it might, as long as you know how to do it some way and get the answer, it works. All right, so remember, let's just say that this is X, right? Remember, X's are just a blanks. We could also just put a blank like that, right? We could put a box, if that makes things a little easier, right? A blank box. So we know when you add these 2 numbers together and divide by 2, you should get 25, right? If you remember, that's what we did in the last example, right? We had 2 numbers in the middle, so we added them up and divided by 2 to find the average. So when you add whatever numbers these are together and divide by 2, you should end up with an average of 25. So if we kind of do a little bit of algebra, so I know this isn't algebra class, but this is one way to do it, right? So first thing you want to do is get rid of this 2, so we can multiply both sides by 2. Let's get rid of the 2. So we have 17 plus something is 25 times 2, which is 50. And then since we're adding, right, the opposite of adding is subtracting, so we want to subtract the 17 to both sides. And when we do that, we see that the missing number is 33. So 33 is our answer. Now, like I said, there's lots of other ways of doing it. Just because I did it this way doesn't mean you have to do it this way. I do have one student who said, okay, well, let's think about this. So we know that 17 and this missing number, we know that halfway between both of these numbers is 25. Well, let's figure this out. What is 25 minus 7? Oh, 17, excuse me. 25 minus 17 is 8. So there's 8 on this side, and if this number is right in the middle of these two, there should be 8 on the other side, right? So then what's 25 plus 8? Yeah, it's 33, which gives us our number, right? So like I said, a couple different ways of doing this. However way makes sense to you, do it that way. If you have a different way and you still got 33, awesome, do it that way. All right, so let's kind of talk about why do we have both the mean and the median? Right, shouldn't the center just be the center? Shouldn't we not have 20 million different ways of doing it? Shouldn't we just have one way? If we already have the mean, why do we need to talk about the median? All right, well, let's look at this. So for this case, right, if we have a sample of data set, so it's 2, 2, 2, and 2, what's going to be the mean of this set? Well, the mean is going to be 2. And again, is the mean going to be mu or x bar? Is it the population or the sample? Well, it said sample data, right? So we know that x bar is going to be 2. What about the median? What's the median going to be? Well, yeah, again, you see the middle number is just 2 again. So both the mean and the median are 2. All right, now let's assume that only one number is added to this list, right? So we have all the 2's and we just add one number. We add a 7 to this list. How does that change our data? Well, for finding our mean, it's still going to be x bar, right? It's still sample data. So 2 plus 2 plus 2 plus 2 plus 7 divided by 2. How did things change? Oh, not 2. Excuse me. Yeah, that didn't make any sense. There's not 2 values. There's 5 values. So when you add these up, right, you get 15. So 15 divided by 5 is 3. But what's the median? Well, if you notice, the median didn't change. It's just 2. So adding one number drastically changed this, right? It drastically changed the mean. The mean went from 2 to 3, but the median stayed at 2. Now, you might be thinking, wait a minute, you said drastically, it's only up by 1. But what if we said that this was millions of dollars, right? Then the mean went from $2 million to $3 million, and that would be a giant change from adding one number, right? As opposed to the median, which stays the same. And if you notice, right, where should the middle of our data be? Well, if all of the data is 2 except for one number, you would think the median should be, or the center of the data should be 2 about, right? Probably shouldn't be drastically changed just because of one number. And if that doesn't make sense, that's okay. But what we have here is what we're going to be calling resistant. So a measurement is resistant if there are extreme values, so really small values or really large values, and we say it's resistant if those extreme values do not affect its value substantially. So in this case that we just talked about, right? Which one is not affected by an extreme value? Because we could say that 7 is pretty different from 2, so which one of these would not be affected? It would be the median, right? So we know that the median is resistant. That is a resistant form of measurement. And the mean is not resistant, right? Because it was affected by one value. So that's why we have the median. Sometimes it's good to have something where one extreme value, it doesn't change everything, even though we do use the mean a lot. All right, last thing we'll talk about for the center, we're going to talk about the mode. So mode just means the one that occurs the most frequently. So as one of my teachers said at one point, mode means most. So it's the one that occurs the most often. It's also the only one that can be used with qualitative data. So if we look at this, what is the mode of this data? So apple, banana, pancake, apple, elephant, apple, calculator, apple. Well, the mode is obviously apple, right? That's the one that occurs the most often. It occurs 4 different times. What's the mean of this data? There isn't one, right? You have to have numbers. And that's why we said mode is the only one that works with qualitative data. Right? The only measure of center that works with qualitative data. Median and mean both need numbers. All right. So, what is the mode of the first list? So, out of the first list, which one occurs the most often? So we can see the mode is 1.10, right? That occurs 2 times. Nothing else occurs after that. So there's one mode of 1.10. Part B, what's the mode? So some of y'all may say that it's 27, because 27 occurs three times. We can also see that 55 occurs 3 times. And then we can see that 88 occurs 2 times. So is the mode 27, 55, and 88? So no, it is not. One of those numbers is not correct. Which one should not be part of the mode? Now remember, mode means most. It does not mean more than one, right? It just means most. So since 27 and 55 occurred 3 times, and 88 only occurred 2 times, 88 did not occur the most times, right? So 88 should not be a part of that list. Because remember, it's most, not more than one. So this is 2 numbers this time, not 3. So 27 and 55 would be the mode. And then part C. So what's the mode in this case? Well, everything occurs 1 time, so basically everything occurs the most, right? So in this case, we can just say that there's no mode. If everything is the most, then nothing's the most, right? So there's just no mode in this case. Nothing occurs the most. Everything just occurs 1 time. All right. So given these 3 ideas, mean, median, and mode, where would they be on a left-skewed distribution? So here's a left-skewed distribution. Which one of these would be the mean, the median, and the mode? All right, so let's think about this. Mode. What does mode mean? Mode means most. So out of A, B, and C, where would the most be? It would be right here, right? That's where the most data is. So C is the mode. So we just got to figure out what A and B is. So now we're going to talk about, now we got to think about what's the difference between the mean and the median. What have we talked about that might drastically affect one number but not the other? Remember we talked about the idea of resistant, right? Which one of these 2 is resistant? Is it the mean or the median? It was the median. So if this is where most of the data is, right, then some outlier way out here should not be affecting the median as much. So down to B and A, which one of these 2 is not as affected by these numbers out here? We can see B is, right? B's closer to the center, so it's not as affected by these as A is, right? A is drastically changing, right? It's getting closer to these outliers over here, even though the majority of the data is over here, right? These outliers, these extreme values, are affecting A way more than it is B. So A, since it is being affected, is not resistant, so A is the mean. And B, since it's not as affected, right, that's going to be the median. All right, let's look at part B. So where would the mean, median, and mode be for a normal distribution? Well, obviously right here, right? Right in the center. That's where the mode would be. So where would the median and the mean be? Actually, if you average all the numbers on the left side and the right side, you should also get right there in the middle. So that should be where the mean is. And also, if you take off all the ones on the left side and the right side and try to find where the middle is, that's also where the median is, right? So for a normal distribution, the mean, mode, and median are all in the same place, which is pretty awesome. That's another reason why normal is just awesome to deal with. All right. So you also don't necessarily need to know this. Most of our homework just will ask you or tell you what to round to, but as a general rule, we always want to round to one more decimal place than the data. So if the data has 1 decimal places, right? So if all the data has 1 decimal, we need to round to 2 decimals, right? If the data all has 15 decimals, how many decimals do we need to round to? We round to 16. Yeah, 1 more. All right. Again, not super important, but if you just want a general rule, that's typically what we do. All right. If you have any questions, let me know. Hopefully this section wasn't too difficult. But as always, if you have any questions, let me know.